Okay, the next problem, a 50 kilogram woman riding a 10 kilogram cart moves east at 5 meters per second. Woman jumps off and lands on the ground at 7 meters per second eastward. Sketch a before and after situation. I'm not going to be good at this, but before we've got a woman on a cart. There's my cart, and there's my woman. And they're both moving this way at 5 meters per second. Afterwards, you've got the cart here, and the woman jumps off, so the woman lands on the ground. And she's traveling now at 7 meters per second. And I don't know what the cart's speed is. I don't even know what direction the cart's going, but I'm going to call this negative and this positive, I guess. And then for part B, find the cart's velocity. So before, we have a momentum of mass of both times the velocity of both. And that's to be equal to afterwards, we have the mass of the woman times velocity of the woman plus the mass of the cart times velocity of the cart. So the mass of both is 50 kilograms and 10 kilograms, that'd be 60 kilograms, times the velocity of both. They're moving at 5 meters per second. I'm going to call it -5 since that's my negative direction. And that equals the mass of the woman, which is 50 kilograms, times the velocity of the woman, which is -7. This time she gains speed in the negative direction. Plus mass of the cart, which is 10, times velocity of the cart. That's the equation we're solving. So -300 equals -350. And then we're going to add this to both sides, so that turns into 50 equals 10 times the velocity of the cart. Divide both sides by 10, the velocity of the cart would be 5 meters per second. And that's positive, so that's going to be, obviously the cart's going this way after she jumps then. Alright, last problem says a male dancer leaps 0.32 meters high. So this male dancer is going to leap up 0.32 meters. And I'm just going to look at this, because it says for the first part A, it wants to know with what momentum does he reach the ground. Well, I'm going to look at it as a free fall problem from the top. So if we're falling from the top, I'm going to do my y information here. The initial velocity in the y would be 0. If we start the problem at the top, we're just falling back down 0.32 meters. The final velocity in the y is what we're looking for, because we want to know the momentum. We know its mass, so we want to know its final velocity before it hits the ground. The acceleration we know is -9.8. Initial distance is 0.32. Final distance is 0. Time we don't know. So we have an equation for that. It's final velocity squared equals initial velocity squared plus 2 average acceleration times change in distance. Final velocity is what we're looking for. Initial velocity 0. So it's 2 times -9.8 times the change in distance, which is 0.32. In fact, actually it's negative point. It's final minus initial, so it's -0.32 technically. Double negatives will cancel, obviously. So we get velocity equals the square root of this quantity, which is 2.5 meters per second. That is the velocity that hit the ground with. Therefore, the momentum would be that times the mass, and the mass is 60 kilograms. So if we multiply that answer by 60, we get 150.3. And then the mass times velocity, so kilograms meters per second for our momentum. All right, now for part B. What's the impulse needed to stop the dancer? We know that impulse is force times the change of time equals the change in momentum. So the change in momentum is going to go from all this momentum to no momentum because the dancer is going to be stopped. So we know that's 150.3. And so that's our impulse. Just multiply this by 3. That gives you about 450.8. And that's impulse, which we can say is newtons times seconds right here. Right, because this quantity is what we're looking for there. Part C then, as the dancer lands, he bends his knees. Find the average force. It takes him 0.05 seconds to stop, so we're using the same equation. We know the change of momentum, or we know the impulse. So if we know the time is 0.05, and the change of momentum is 450.8, we can divide both sides by 0.05. That gives us 9,015.8 newtons is the force. Part D, compare that stopping force with his weight. So we'll just take this and divide by the weight, which his weight is 60 times 9.8, which gives us 588. So 9015 divided by 588 gives us 15.3 times his weight. All right, hope this helps.